Hello and welcome to this Norsepower webinar, the second in a series of webinars from Norsepower. Thanks very much for joining us. The title of today's discussion is Powering Shipping's New Build Decarbonisation Drive, where we want to explore the benefits of incorporating wind and other clean technologies into the new build designs as part of the huge challenge of decarbonising the shipping industry. And I'm delighted to be joined by a very experienced and knowledgeable panel, particularly when it comes to the new build market. And they are Hasso Hofmeister. Hasso is the Senior Principal Engineer at DNV-GL. Esa Joikinen, who's Sales and Marketing Director at Deltamarin, and Thomas Risky, who is CEO of Norsepower. Very briefly, just to set the scene, I think we discussed on our last webinar, which also included Maersk tankers, the retrofitting of the rotor sails on the Maersk Pelican, which proved to be very successful with a savings of 8.2% after a year of sea trials. But there is also a huge opportunity in the new build market for installation of the rotor sails and indeed clean technology more generally. And as we look to low carbon fuels, which invariably are not yet available to the market, there's going to be a need, a necessity for significant investment in energy efficiency and, in the case of the rotor sails, other renewable energy power generation to bridge the gap, if you like, to those new fuels. And so with that in mind, I'd like to turn to our panel. And our first question, when it comes to the shipyards. Gentlemen, what should shipyards consider when designing and building vessels to comply with increasing demands for energy efficiency, as I've just mentioned, and reducing emissions? Perhaps, Hasso, you could take that one.
Yeah, why not? Well, I think, thanks for that question. I think for the time being, and I think that is really important to notice this fact, new builds need to fulfill the EEDI, which is the Energy Efficiency Index mandated by the IMO, MARPOL Annex 6. And this index is actually representing a so-called mathematical ratio between the CO2 air pollution divided by the transport work. So we might ask ourselves, where do we now work on? So above the fraction line on the side of the air pollution, there's obviously several parameters as factors that can be influenced. So there's options like reducing power, the use of alternative fuels. There's options like air cavity or lubrication systems. Also, I heard there's a waste heat recovery, but only used for generating electric power. But there's also wind assistance. So I think it will be subject to those topics above this fraction line to achieve the improvements. But at the same time, I think we will have to prepare inside of for and perhaps rather unknown future regulatory requirement and act real flexible on the use of perhaps also different fuels. And to finalize this, I think that wind propulsion in that respect seems to be a safe and really sustainable solution.
Thanks, Hasso. And Esa, picking up the same question.
Yes, I agree with Hasso on that one. And it's quite evident that there will be new regulations, not only from IMO, but also from financial institutions, banks, charterers, and so on, moving forward. And how I see this is that we are not maybe yet, but in the coming future, running out of the conventional tricks in in optimization of the hull and propulsion and these conventional things. So we need to have more and more look into energy saving devices like of wind power. With that said, of course, the efficiency of the ship hull and systems remains to be, of course, extremely important. But as we really need a step change in the performance in the coming years, we need to look for new alternatives. And getting back to EEDI and what Hasso pointed out about that, I think one of the big differences moving into future will be that it's highly likely that there will be also regulations that are looking beyond the vessel delivery, likes of a carbon intensity index, and that actually means that it is not enough to design and build the vessel only to have a pass on EEDI. You need to make sure that it's also efficient in real operation, and that of course then puts more and more, how would I say, challenges and requirements on the design stage. How can we really understand how the vessel is operated as well?
Thanks, Esa. Just a quick reminder to our audience as well that we will be aiming to take your questions towards the end of this session. And if you have any questions, please post them in the Q&A, which should be fairly obvious to find. Thank you. Thomas, turning to you, when it comes to the dealing with the shipyards in terms of the installation of the rotor sails as a new build, what factors really do I guess ship owners, operators need to consider?
Yeah, I see that rotor sails are very efficient way to reach fuel consumption reductions and emissions reductions also. In typical cases, we can reduce the fuel cost and emissions between 5 and 20%. But what I'd like to see on the market, that when we make new builds, of course, we can gain better efficiency with the less installation cost with the new build cases. I would like to see that we start earlier. What would be welcome from the shipyards from the market is like concept designs readily integrated rotor sails included in those ones. So that's something I'd like to see, earlier actions and more ready-made efficient designs with compatible technology like rotor sails.
And just extending that question to Hasso or Esa, I guess more generally, how can we see the shipyards or some of the shipyards engage more at that early stage, as Thomas alluded to?
Well, let me mention some from the glass society point of view, some practical terms that we experience. I deem that a rotor sail can be added to a new build fairly straightforward, provided that the structural integration of the foundation can be realized and there's no major aerodynamic obstructions on the ship, such as container stacks or shipboard cranes, but also line of vision, radar, blind sector, and navigational lighting need to comply perhaps with all the statutory requirements, and that is sometimes a challenge. So the integration of energy demand of a rotor and the integration of a control system should not be a major change. But I think depending on the relative size, so let's say the dominance of the rotor in comparison to the ship, possibly stability needs to be assessed. And if stakeholders want to prepare for all these challenges, we at DNV-GL recommend, for example, in a very early stage, and then this way I'm coming back to your question, Alistair, to have like a risk assessment carried out. So that is actually satisfying perhaps different stakeholders' needs to satisfy unknown challenges, which we do experience at this, let's say, still pioneering ages, if I may say it like that. So there are possibilities to carry out risk analysis, hazards or something like that, or at a later stage also an approval in principle to prevent any major obstacles, the concept from being realized.
Thanks. Esa, anything to add to that?
Yes, maybe more on the commercial side. So of course, from a from our point of view as a designer, of course, all the points that Hasso mentioned are highly relevant, and then of course, in the end of the day, how this integrates to the overall performance of the vessel. As we know, there are certain things also that we need to mind when it comes to not only stability but also the performance of the propulsion system, steering, and these kind of things. But really, what is I think critical for the shipyards to get right is to understand what does it actually mean to have the rotors on the ship, because it's not only to arrange the space on the deck and there you go. So there is, like Hasso pointed out, both the structural integration as well as the automation integration, and the more we can define that in the, how would I say, tender stage of the shipbuilding project and before the shipbuilding contract, the more likely it is that the shipyards get the price right on that, and that then leads to a positive decision on the investment on a tech like this. So recently we have really worked a lot with many different technologies and this aspect, how to really make the tenders for the shipyards unambiguous related to integration of new tech.
And just picking that up, and this is to all of you, do you feel that the assessment process and the processes in general work well enough? Is there some variation between shipyards that you were seeing? Presumably some are more sort of progressive than others, I guess.
Well, we at Norsepower, we have currently the first new build ship on build to be fitted with rotor sails. One of the first cases globally in the world, and I think that's going quite fluently. We started the process early enough. I agree that there are a lot of details, like Hasso mentioned, to be sorted out before you can actually decide on investment and start fitting the rotor sails. But I really see that in a new build case, you can optimize things far better. We have proven that we can do retrofits without technology, but in a new build case, you can optimize the main engine better, the propeller better, the deck space better. You can just make it work. You perform better with rotor sails, better with the entire ship, and the cost of installation is a lot smaller in a new build case. So I can see that we are going to the right direction, but as I mentioned, we have to start early enough cooperating with the shipyards to make it work.
Yeah, I agree on that. So if the rotor sail is planned early in the beginning of a concept stage, the design concept might have a lot of room for optimization, whereas opposed to a retrofit. And this may be regarding the hull design, the placement of the rudders. Well, again, depending on the dominance of the wind propulsion system. So the bridge position may also be an important issue to solve, stability, as I mentioned, and maybe it even comes down to the recovery of energy when the ship at times could be potentially in future business propelled purely by wind assistant, at least when there's favorable wind.
No, that's really interesting. Esa, anything to add to that?
Yes, I think what Tuomas and Hasso pointed out is entirely correct. Maybe just to mention these two different layers of information. So we have all of this related to the ship concept from the very beginning. But then when we know what shipyard is going to build the vessel, there's going to be also the shipyard specific issues that we need to mind quite carefully. Restrictions in production, restrictions maybe with taking the vessel out from the shipyard, and these kind of things that will then have to be added into the plans. So I think the key thing here is that we need to provision the shipyard with the right information at the right time, and that is not only in the pre-contract stage, that continues throughout the design and building process.
Thank you. I guess for a relative layman like me, what's coming across here is the earlier you can work within a network of presumably design engineers, the yards itself, the more advantageous potentially the installation can become, given what you were saying, Hasso, about even the potential for the bridge to be repositioned in terms of optimizing the efficiency of the vessel. It's fascinating stuff. I just wanted to open it up more generally to clean technology. We've heard about EEDI. We're all aware of EEXI, CII coming in, all these abbreviations. There's AER from the Poseidon Principles. There's a tremendous amount of regulatory and non-regulatory pressure being applied to the industry that we're going to see intensify over the next few years. Are the shipyards doing enough, really, to support the sector? Have they really got their heads around this in terms of accessing clean technologies? And what can be improved in order to accelerate this installation? It seems to me, I'll be honest, from the outside looking in, that it's a little bit disjointed. Esa, perhaps you can take that one up.
Yes, well, from my perspective, I see this mainly as a market-driven thing. So if there are ship owners or end customers who are requesting for environmentally free clean tonnage with, may that be flatness or something else, yards will eventually offer those. And then the outcome is sort of combination of techno-economical factors. But really, I do think that the yards that are most flexible in customizing the designs, listening to the customer, and most importantly, offering these vessels at the right and a fair cost, not putting too much, how would I say, premiums on the new tech, like it maybe in some cases they will come out as a winners. But really everything starts from the customers and the market.
When I today look at the customer and shipyard market, I see new ships being built. I think the factor, in my opinion, which will mostly define the second-hand value of the ship will be energy consumption in long term. Those EEDI and EEXI, they are hitting hard, and what defines how expensive or valuable your ship is as a second-hand market, it will be how much fuel it consumes, how little emissions it causes. So I really like to see shipyards taking it up and making ready-made designs with energy technology fitted on board. For example, we have already made concept designs. They have been published with Hyundai, Samsung, and SWS from Korea and China. I think those are good examples how to offer to customer environmental designs to maximize your asset value in long term.
Thanks very much, guys. I want to turn to, I guess, what's probably most important for those investing in clean technology, and particularly Rotor Sails. So what the savings can look like, both in terms of the fuel costs, and of course, carbon emissions and other emissions. Thomas, going back to you, please, first of all, what differences can we expect to see in terms of fuel saving and emission saving performance on new builds versus retrofits? And I realize to some degree it depends on vessel type and other particular circumstances.
Yeah, a lot of factors influencing that, like the ship type, service speed, operational area, wind conditions there, and so on. I think our best reference is Maersk Pelican. We were proven to save in fuel cost and emissions 8.2% during 1 year period. But that ship actually wasn't sailing on the windiest seas of the world. When we just take those forces and results from that project, we foresee that we can reach 5 to 20% savings in fuel cost and reduction in emissions with that type of design of rotor sails on board a tanker. I think that's quite impressive figure. So that's something we can expect between 5 and 20% without changing the operative speed of the ship.
Hasso and Esa, sort of extending that same question, if we can start to see some significant savings on some of the new build vessels from Rotor Sails and other clean technologies, as we move forward and as the regulatory pressure intensifies, and indeed wider so the societal pressure probably intensifies, what can this emissions reduction technology achieve in terms of the asset value, in terms of the attractiveness of the vessel to charterers? Presumably there's got to be an incentive beyond compliance here. Maybe Hasso, you could pick that up.
Well, yeah, I can perhaps speak only broadly about that, and perhaps in the line of what Thomas already said. I think the reduction in emissions is purely or mainly depending on the size relation between ship and wind propulsion system. So I consider, for example, Maersk Pelican to be, let's say, a moderate wind propulsion system size compared to the size of the ship. So I agree that a potential is given to achieve higher savings with, for example, with smaller ships or with slower vessels. We have been recently asked whether it would be possible or permissible in general to switch off a main engine when favorite wind conditions are existing. So that tells me that the amount of savings can perhaps obtain a fairly broad range. So I think that question suggests that potential savings can be fairly promising. But I also agree with Thomas that all that must be seen in relation to other influences, such as the geographic area where the ship is operated, and also the service speed which the ship is currently run. And this is because wind propulsion is particularly effective in the lower speed range.
Thanks, Hasso. And Esa, same question to you?
Yep. So first of all, when it comes to this saving range, for what we have simulated and calculated so far, it's on the same range as Tuomas pointed out, so up to 20% in maximum, but of course heavily depending on the route and the speed of the vessel and many other factors. And we just recently looked also into this Maersk Pelican, and it seems that our calculations on that area for that type of vessel with 2 rotors are actually matching very well. So if those results scale as we think they do, that's a very, very good thing. Getting back to this kind of a asset value discussion and investment discussion, my observation has been that more or less over the last year, more and more of our customers have started to use carbon price or carbon tax as part of evaluation of these investments into new tech. And that can be anywhere up to $100 per ton. It's quite interesting how that suddenly changes the payback calculation, and a lot of technologies that didn't necessarily make sense at the time of low fuel prices suddenly start to do so. So I think we are going through a very interesting period in shipping and shipbuilding when these kind of things come into the picture and so to say the game changes slightly.
Yeah, and that would go back to what I think it was you were saying earlier, Esa, where ultimately behavior patterns will change when market drivers change, presumably.
Yep, that is true, and compliance is a strong driver in the industry. So what one can expect, one should look into regulations to see what's coming.
Thanks for that. And I think, I speak on behalf of the audience here. When you talk about the Maersk Pelican, and that was a relatively small installation for the size of vessel, and the potential of scale looks good. You said, quote unquote, a good thing. Could you give us a flavor of the sort of ballpark percentage savings we might be able to see on a new build vessel of a similar size?
That's a
Putting
good
you on
question.
the spot.
That's a very good question. I don't have that number, unfortunately, in my head. But if you would double the amount of rotors and put it into a more windy operation area, I think you could go closer to this 20% that Thomas mentioned. But of course, this is highly depending on many things, and it's also sometimes a bit misleading to talk about only the percentages, because that you would need a reference point to that. So what we have also observed that, of course, this and clean tech has a lot to offer, but it also depends a lot on what kind of vessel that is installed. So the underlying vessel has to be high performing as well.
Yeah. No, thank you for providing that answer and completely understand the caveats from your position, but it's very useful to get a flavor of the potential. And with that in mind, one of the things that certainly I've been observing is that the incentives for investment beyond regulation, beyond the outside pressures as well, include the fact that almost certainly any new fuels, whether that's ammonia, hydrogen, biofuel, bio-LNG, are going to be more expensive. And therefore, the rationale for anything that saves fuel becomes all the more obvious. Hasso, just looking ahead to 2030, is this something you're seeing at DNV as well? That, you know, energy efficiency, fuel reduction with the likes of the Rotor Sails is going to be ever more important?
Yeah. You know, we recently carried out a poll on whether operators of existing fleet feel currently prepared for complying with the mandatory EEXI certification required from 23. And the majority, they stated they are not. So I conclude that there might be a lot of work coming up for conversions and things like that. And starting with the new phase 3 of the EEDI, shipyards will probably not be able to satisfy requirements anymore with their conventional solutions, so with business as usual, but have to think out of the box, accepting the new alternatives to satisfy the stricter limits. So the 30% improvements you're talking about with reference to the 2008 EEDI limits.
Thanks. And Esa, same sort of general question, looking ahead at the overall picture.
Yes, it's, how would I say, the fuel thing is quite complicated. I mean, there are of course alternatives regionally in certain places, but really globally only LNG starts to be a true alternative for the conventional oil-based alternatives. And when we think a little bit further, one might think that there will be biofuels, for example, to go with. My personal thinking with that is that probably the road transportation is more capable payer or has the possibility to use that fuel before maritime industries. But of course, road traffic is also going through a quite rapid electrification. So one day we might have bios available, who knows? And in the end of the day, I guess the end game is that the fuel palette will be much more diverse than it is today. But really in the meanwhile, like you pointed out, I think all the technology that is not linked with the fuel choice is becoming more and more interesting and important, because we do not exactly know when and what fuels are available globally, but we can be quite confident that wind will always be there.
Yeah, thank you. And I'm just slightly segueing, Thomas, into some of the questions from the audience as well, linking to what Esa just said. I mean, can you give us a flavor of the interest, and I think increasing interest in Norsepower and the Rotor Sail? And a second part to that, you know, in your experience, are financiers open to the integration of the technology, you know, which this is the questioner, which from their point of view may not yet have sufficiently confirmed its efficiency in practice. So I guess just to paraphrase, are financiers happy with the results you've already shown and some of the potential results you're envisaging for new builds?
Well, I see that the interest on the market towards our technology is increasing at a very, very high rate. Latest IMO decisions have changed the market quite a lot. Energy cost is increasing all the time, and to comply with EEDI and EEXI regulations, you just have to reduce the fuel consumption and all emissions. So I see two types of demand for the rotor sails in longer term, and for any technology. You have to comply with the requirements, and also the energy cost is increasing, so the paybacks are getting shorter. So it's all the time a better business case to make these investments. I see that also the financing sector is with us here. There are Poseidon principles and other good examples examples of ways how financing sector is willing to invest in green technologies also in shipping. But I think the underlying case is that they want to finance ships which are efficient, because their asset value will be a lot better in long term. I think that's how the market is working today.
Thank you. And then sort of back to you, Hasso, maybe Esa, another question. What, in your experience, is the current willingness of the shipyards to incorporate rotor sails within their shipbuilding contract performance guarantees to the owner? Is that something you've come across yet?
I think if I'm starting, Esa, the interest we see from shipyards, but not only those, but also especially from owners. But if your question related to the shipyards is increasing, certainly. So we are, to be honest, we are overwhelmed by inquiries from actually, I would say, all sides of stakeholders that are involved with this realization or with this concept of wind propulsion. So it's not purely the shipyards, but it's also the designers of wind propulsion systems, and it's also from the financing point of view. There's a lot of interest in this technology. So we see the interest, let's say, fairly broadly distributed among all stakeholders to a fairly even degree, I would say. So which is a good sign. So there's not much resistance in, let's say, one part of those stakeholders. So that looks really well, I think.
Thank you. And just quickly picking up that contract performance guarantee, is that something that, you know, you're seeing that yards are willing to sign up to?
Well, that is quite complicated and complicated question, so to say. So how we see this is that what we see from the market is that the owners really want that the yards take more responsibility of the vessel rather than only building it and after sea trials and delivery say, here you go. That kind of this performance guarantees is one thing, but more we see that there is a desire to have maybe co-investment, maybe leasing schemes to ensure that the vessel is operating efficiently throughout its life cycle. So I wouldn't pick up this traditional way of thinking about the performance as the way forward, but more really bringing all the parties closer throughout the life cycle of the vessel.
Yeah. And Thomas, that seems to be a recurring theme, collaboration and partnership. I think we're seeing more and more requirement for that as regulations and compliance intensifies, as outside pressures intensify. Would that be something you agree with?
I totally agree with that, and as I mentioned already, I really wish that dialogues of fitting rotor sails and other kind of technology on board newbuild ships can be started as early as possible. When you have enough time, then you can really optimize your ship. You can make it perform even better with rotor sails, and the cost of installation is always smaller in the newbuild case. For example, the foundations for the rotor sails, I'd like to see that they are built as integrated part of the hull. When the hull is made, you make the foundations in the same time. If you don't take it with that kind of attitude, then it in a way becomes a retrofit case, and you lose the advantage of making a fully optimized new build case.
Mm.
Great. Thank you.
It's really important to note that already at early design stage, the involved parties should work on that concept together and commonly drawing on one side of the rope, so to say. So that's including operators, owners, designers, builders, well, the wind propulsion system builders, the shipyards, and not to forget about the class societies and flag states, and probably or hopefully all in a coordinated manner. And I think that's in this respect pretty important to note that we are still dealing with an, let's say, unusual technological solution, probably a solution that not all of these stakeholders are really used to, so it's not a business as usual. So it's a new topic, and it requires to address early. That's also our recommendation. Yes, I agree with that.
Thank you very much, Hasso. Sorry, Esa, please go ahead.
Maybe just an observation from my side is that yes, we are more and more talking about wind-assisted propulsion, but at the same time we are looking at many other ESDs as well, and what is going to be more complicated in the future is to make all these things work ideally in a tandem. So we shouldn't only talk about a certain thing in isolation, but it's the complete ship and all the systems all together that has to be optimized, and that is going to be highly demanding if you don't make those choices early enough. If you drop things in too late, or maybe only after the vessel has been built.
Yeah, I think that's a really good point. We hear a lot and read a lot about the fact that to get to the sort of savings that will ensure that your vessel and fleet remain competitive, we're going to have to explore multiple technologies, and that integration is important. And I guess that goes back to the yards. Just to start concluding, Hasso, the yards being more integrated, being more part of that sort of collaborative approach at that early stage.
Yeah. As I mentioned, it's important to involve the shipyards in this new technology. That's for sure. That's not much more I can say about that.
Yeah, well, let's hope a few of them are listening today. And just to conclude, back to you, Thomas. There's one question's come through. Based on current trading, what percentage of the global fleet would be suitable for the rotor sails when it comes to new builds? So when owners and operators are renewing their fleet.
It entirely depends on the price of propulsion energy, price of fuel, emissions trading, taxes, those kind of items. Our forecast today is that in the so-called global average wind conditions, we should be able to reach less than 4-year payback period with our technology pricing within 4 years from today. But when the energy price is increasing more and emissions trading is getting in, I see that kind of area is widening across that average global wind condition of the seas. So I actually think that in long term, nearly all seas we should see a feasible business case for wind propulsion. But as said, today the best business cases are on the windiest seas, and that's where we mostly see in short term wind propulsion devices.
Thank you, Thomas. So just to conclude, I think what we're hearing today, and thank you so much, I think it's been fascinating, is that still yards will be driven fundamentally by the market, and those drivers are only increasing. I think there's an opportunity perhaps for those yards that are a little bit less driven by market and can see the slightly longer term and bigger picture. In that sense, not charging a premium for new clean technology strikes me as being one opportunity for some of those yards, and certainly a more collaborative partnership type of approach, including financiers, including class societies, engineers, designers at a very early stage. From what I understand, from what we've been told today, will reap rewards later in terms of the operational functionality of the rotor sails and the vessel. But it's been really interesting, gentlemen. Thank you very much for your time, and thanks to our audience for joining us today.
Thank you.
Thank you, everyone.
Thank you.
Thank you.